Good evening, everyone. I'm Mahirah Jahari, doctorate student in second year. So today I will present about my second project, which is rice grading for sake brewery. So this is outline for today's presentation. First, introduction about the rice characteristic, which is good for sake. Then we go to the objective of this purpose of study, which is to discriminate between these four types of rice kernels, and then followed by the device and methodology. Lastly, the preliminary results and the future plan for this project. As we know, sake is an alcoholic beverage of a Japanese origin, which made from fermented rice, and sometimes it called rice wine. But the brewing process is more as a rice beer, which is converting starch to sugar for the fermentation process. And the rice which used for brewing sake is called Shuzo Kotekimai, and this grain is larger, stronger, and contain less protein and lipids than the ordinary rice. As we can see here, this is some types of rice that we have in Japan. These two rice is an ordinary Japanese rice that normally we eat in our normal daily meal. So this is a white rice from Koshihikairi variety, and this is a brown rice. For this kind of rice, it has a sticky texture when we cook, and the rice kernel is oval shaped and translucent, which means transparent. And the second type of rice that we have is gelatinous rice, which known as mochigome. So this kind of rice now in Japan they used to make a mochi. This rice kernels is very round shape and has a cloudy color. And the last one is rice for making sake. So this type of rice is pebble shaped and have a fluffy texture. And at least we have 80 types of sake rice in Japan. And this is a type of very popular variety of sake rice. And the most popular is from Hyogo Prefecture, which is Yamada Nishiki. And then we have from Horikuru and Tohoku, which is Gohyaku Mangoku. And from Nagano Prefecture, we have Miyamanashiki. And the last one is the oldest sake rice variety, which is from Okayama Prefecture, which is Omachi rice. As we know, rice contains various of elements. Some of the elements are good for sake brewing and some is not good. For example, the starch component. For rice, for sake, normally we need about 70 to 75% of the starch, because this starch will be changed into the sugar. And the second element which is important for sake is the chemical element. For example, potassium, calcium, and magnesium. This chemical element is necessary for the growth of microorganisms. And protein and lipids, less is better, because protein will change into amino acid by the enzyme which produced by the koji, so it's bad for fermentation. And lipids, if we have a high content of lipids in our rice kernel, it will influence the aroma of the sake. And also for the vitamins, vitamin concentrated in the germ, so it also not necessary for sake. Quality of rice as ingredient of sake can be estimated from several physicochemical properties, which is protein content, water absorbability of grain, and the weight of 1,000 grains. It means for 1,000 grain kernel, it should be weighed as about 25 to 30 grams. Compared to the ordinary rice, for 1,000 grains, it only about 20 grams. And also, we can estimate by the moisture content and the occurrence of white core in the center of the grains. So, for this study, we will focus in the occurrence of white core in the grains. The white core is an opaque region which located in the endosperm of the rice. For Japanese, it's known as shinpaku. It is important character of the grains of the rice for sake. Some literature said this is like a white heart of the rice for sake. So this is example of rice kernel which contain white core. The white core will absorb water quickly and steam well, and will increase the ability to gelatinize during steaming. The white core has a softer center for koji to invade once it breaks through the firmer outer layer, and more highly convertible by the koji enzyme. This is an example of koji. Koji is a filamentous fungus, and it used to saccharify rice, which means to help to break a complex carbohydrate into a monosaccharide components, which is sugar. So, as I mentioned earlier, we have 4 types of kernel given to us, which is dead rice, rice with non-white core, rice with white core, which is good for sake, and chalky rice. So, from this figure, we can see that dead rice, the color is more like a brownish. So, it's easy to differentiate between this and 3 types of rice kernel. And for rice with non-white core, the kernel is very transparent, means translucent. But the problem is the rice with white core and chalky rice. It look like a quite similar. So, in 2002, Yamada-san have made research about the difference between rice kernel with white core and the rice kernel with non-white core. He used a scanning electron microscopic and to see the ultrastructure of starch granules in the white core and non-white core kernel. He found that starch granules in the white core, they have a space between the cell. The cell is small and disorganized. And compared to the non-white core kernel, the starch granules is tightly packed into the cell. So this is the difference between the white core and non-white core. And according to the book, which is Rice Chemistry and Technology, it said that the difference between rice with white core and chalky rice is the location of the white core. If the white core located in the center of endosperm, so they call the kernel is a rice with white core. But if the white core is almost cover all the endosperm, so they call it as a chalky rice. So our objective is to discriminate between these 4 types of rice. If we manage to discriminate between these 4 types of rice, so the next objective is to discriminate between the level of white core. We have 3 levels, which is level 1, level 2, and level 3. Level 3 is the most high quality rice for making sake. So first task that we do last time is to see which wavelength can discriminate between these 4 types of rice. So we measure the reflectance of the rice pellet. We crush the rice and compress and make into a pellet like this. Then we measure the reflectance of this pellet. From this figure, we can see that dead rice give a big difference compared to the other 3 rice. But for the white core, non-white core, and chalky, the difference is very small. And last time, some suggestion given to us said that maybe the reflectance by the rice pellet is not represent the original rice kernel, because we already crushed the kernels and compressed. So the structure, the shape, and the color are already changed. So next step is we want to check which wavelength suitable for differentiate these four types of a grain by using the original kernel. So I set up a system by using UV camera, and the lighting system is halogen lamp. And this time we use this one, which is a liquid crystal tunable filter. It can change from 400 to 720 nanometer. So this experiment is just begin, so I only can show the image that already taken by the system. And as I mentioned, the tunable filter can measure from 400 to 720, but even though 500 nanometer, the image is very dark. I already changed the shutter speed, the gain, the offset, but we still cannot get the image below than the 500 nanometer. So what we can get is from 550 and until 700 nanometer only. So from the figure, maybe quite difficult to see the difference between these four types. So I will try. Next step is I want to analyze this pixel value to see whether they have a difference between these four types of rice kernel. The second experiment that I conduct is by using backlight system. This time I use UV camera and halogen lamp without using the tunable filter. And from this experiment, we can see that the dead rice is have a low intensity, so become very dark. And as I mentioned, non-white core is very transparent, so you can see it's very clear here. But the problem is for white core and chalky rice, it look quite similar. So from this result, I can say that we can break into three groups, which is dead rice, non-white core, and this white core and chalky rice in one group. So for the next plant, I will analyze the front light and backlight image and see the difference between those images. And it seems that backlight image gives some possibility to discriminate between those type of rice. So I will try to take the backlight image using liquid crystal tunable filter. So hopefully some wavelength can differentiate between the chalky rice and white core rice. That's all. Thank you.
Show us the reflectance again.
Green.
White core red. The red is lowest.
For this project, image is better than the spectral. Contrast is important to evaluate to find the core, sector core. So I think this test not so important. After result, to usually to image, tunable filter image, and other one is UV.
That one is backlight.
Backlight. And
UV camera.
UV camera. Why you use UV camera?
UV camera have a wide range. 200 nanometer to 900 nanometer.
UV camera, but
UV.
You use a visible range and the infrared range. No UV range. Another way is Satake companies, they may simulate and one kernel by one kernel fly from some place, or coming down, going down, then better. So that's which way you try to do it?
Last time, during the previous group meeting, I present this project. Then Fujira Sensei also said the same thing, but last week he gave me the journal of Satake in Japanese, so I don't understand. And he said the Satake company use a one-dimensional image, right, Sensei?
One-dimensional image.
They use the photodiode, and that in that paper, Satake only differentiate between dead rice, green rice, and good rice. That was told by Fujira Sensei because I already searched the journal from the Satake company, but all the journals is in Japanese. My Japanese is so, but I will try to look again.
The company made coming soon.
Okay. So,
Yeah, he's a specialist for this.
Okay.
Show me the result of
Which one? This one.
So from this multi-spectral image, if you want to get spectral information, first you have to take reference.
And take.
Because even imaging area is not uniform characteristic. So first you have to take reference image. So
Last time I used the white nani. BASO4.
Then you already take such a reference data. Then this
For each, if every time I change the wavelength, I take the reference. Means the reference picture, and then the image.
this is reflection.
This one.
Right?
Hi.
After calculation.
No. I just take this picture.
How you calculate?
I
Or the some
I never done any analysis yet. Hi. Okay. Which means I use this image with the reference image, do calibration.
this I couldn't understand. Why you can't get your image in 100 millimeters?
I also don't know. It's very dark because I already adjust the shutter speed and also the gain, and also the offset of the camera, but still dark.
How about reference?
No. I don't know why. Maybe Kondo Sensei.
What's the condition of this? The length, distance between this object and the lighting devices, how many centimeters? This one? 10 centimeters?
Really? This is a camera from here.
Camera is okay.
This is maybe
Yeah, lighting
more than
device.
more than 20 centimeters.
I'm talking about 10 centimeters.
Lighting device.
Because dark.
Oh.
Dark means more
light.
closer condition. Can get the bright.
Okay, I will try.
This is a front lighting image. Back lighting image also certificate by using that tunable filter?
Oh, last time I just tried by using UV camera and the backlighting system without the tunable. So I don't know, maybe we can.
So I'm worrying about the sensitivity. Tunable filter is very thin, like interference filter. So might be dark, but if backlighting device is very high power, maybe possible.
My plan.
If you get this image is by tunable filters, it will be very, very precise, and you can combine the 2 or 3 images calculation. That could be better.
But okay.
Any other suggestion? By the way, you entered 2 years ago.
September.
That means that
September.
you have 1.5 years left. That's right. You are graduating in September. Next September. Not this September. Next September.
Hopefully.
But time flies. Time goes fast.
Okay.
Please submit the paper.
Thank you.
Okay, thank you very much.